Hi and welcome. So, I want to explore as to how simple it is to create a neural network with R and compare the same thing with Python. So, how quickly can we do that with some basic data set? So, the reason I am doing this is I will get into details of neural networks and do some kind of computer vision experiments, I must say, and also some kind of other pattern recognition experiments. So the first thing I've gone and done is I've picked up some old code from here from one of my earlier markdowns, and like I did earlier, I will also go ahead and post this code on GitHub along with this video. So we are importing two libraries here, basic libraries, NeuralNet and NNet and NeuralNet. We import iris, we look at the head of iris so that we understand as to which are the variables and what is it that we want out of that. So when we look at the head of iris, what we get to see is we get to see the variables. So the variables that we have are sepal length, sepal width, petal length and petal width, and of course the fifth one which is there is the class that they fall in. So what kind of flower is it? Is it setosa? Is it some other versicolor or whatever is there? So what we want to do is we don't necessarily want these species names over here. We want some kind of numerical code. So we would want a 1 or 0 or whatever. So if it is, say, setosa, we create a column, and if it is this S thing, then we go ahead and code that with a 1. If it is not, if it's not one of these and it's some different flower altogether, then we go and code it with a 0. So that is what we want to do. So how do we end up achieving that? So what we do is we create a training data. So this training data I've already done, and it's already visible here. So what this basically does is it c-binds the first to fourth column of iris, leaving aside the fifth column, that is the actual species name, and then it creates an index with that species name. So if we were to go and see this, this is what we get: sepal length, sepal width, petal width, setosa, versicolor, virginica. Yeah, so this is a very basic neural net, and whatever little bit that we can do with R. And the data set is I'm sure everybody's already seen this. So the structure of iris we are already aware, so we'll skip this bit. And next we go to create a helper for creating a sample. And where did I get this code? I got this code from this particular site. So this particular site is basically okay, anyway, so you can see that later on. So this particular site is the NNet packages, the official this thing, so to say, and that is where they've taught you how to go ahead and create a sample in this particular manner, and we just taken that from there. Now the actual building the artificial neural network. So the library is called NeuralNet. So we import this library. We go ahead and create a neural net with the name NNIris. So what are we giving it? We are giving it the 3 species, and we are giving it the sepal length, the sepal width, the petal length and the petal width. So basically what we are doing, we are regressing. So this little thing over here, which is called the TILDE, is basically the indication that we are regressing these independent variables onto this dependent variables on the left side. So basically what will happen is the classification task will use these independent variables on the right side, which is sepal length, sepal width, petal width, and it will go ahead and classify basis these 4 inputs, whether a flower is a 1 over here or a 0 over here, or so sorry, I'm pointing at the monitor. So whether it is a 1 or a 0. So if it is a 1 under the setosa, that means that flower is actually a setosa or a versicolor or a virginica. So again, now we create the train data by using that SAMP that we created on top over there. So it takes out, it extracts the train data basically, it creates that structure for you. Then hidden and threshold are got to do with the nodes or the nodes, so to say, of the neural net. And I'll come to explaining all of this. I'll do that later. And the step max, the algorithm, the error function, all of these are and the actualization function, so to say, is the logistic function or the logistic regression, the sigmoid function. And now we want to plot that and we want to see. So you just end up running this chunk of code, which is not many lines of code, and you get this wonderful plot over here. So what is this plot showing us? That the input is these variables. These variables are the input, sepal length, sepal width, petal length, and these are the various nodes of the neural network, and these are the outputs. So we'll go into we'll go into further detail of this, try and understand what this error is, what the various things are being printed out on the console. So what exactly is all of this? There is a large amount of printout on the console, which when I share this code will be visible, and by then I'll also explain as to what all of this is. Right, so in my next video itself I'll explain that. And this is another basic code chunk in case we want to just go ahead and do something even much more simpler. Then you can go ahead and use this code. Most of it is quite self-explanatory also, but what it gives us is a difference. So the number of layers which are there is different. So this is just 2 nodes over here and just 1 layer, whereas what we saw over here, just to kind of we'll slightly cheeky about it, this is a deeper neural net in comparison to the other one. So this has got more number of layers, and you can see back propagation much more effectively over here, because there's lots of to and fro happening. The error over here differs from the error here, and the steps also. So this seems to be slightly better, or rather a whole lot better, but we'll come to all of this. And then of course there's a related post of mine over there, so something that I tried with Veka earlier. I'll explain all of this, and then once this is done, we shall move next to the classification of various images. So the images, how do they get classified with neural networks? And of course I will get into the Python code and OpenCV code, and I'll explain that. So there are some basic things with the Python and OpenCV which I've already kind of done. So let me go ahead and explain those. Let me just pause this for a minute and get my Jupyter notebooks up. Okay, now this is the very basic setup that I have for computer vision with Python. So to even say that this is basic is again actually wrong. This is way basic. So this is just the beginning of computer vision with OpenCV and DLIB, and I'll leave all of those links, and those are common libraries, so it's not as if we're doing something fancy here. So those are very basic common libraries which are used within the Python programming setup for OpenCV. So what exactly is OpenCV? So it's open sourced computer vision basically. And what is DLIB? Again, DLIB and DFib, and there are few other libraries of that sort. Those are again open source libraries maintained on GitHub by some wonderful people, very helpful maintainers. I myself had some issues and they kind of helped me out. So having said this, I am picking up few examples which are from within OpenCV and DLIB examples, open sourced examples that they have shared on their own websites, and I'm just trying to begin with that. So I'll try and be as much detailed as possible. So what do we see on the screen? So it's a Jupyter notebook basically, and the first chunk itself we are importing NumPy and CV2. So CV2 is basically computer vision 2. I ended up installing CV 3.0 on my Linux systems. And Linux is, of course, this one is 16.4, and it was slightly tough because I ended up messing up my Python path, and then I ended up messing up my basically some path which I was supposed to define, and I was advised to go ahead and change my LD config or something, but of course that was not required. So I just went up and made some changes in my bash RC, and that's about it. So okay, so firstly we want to create a face classifier. So what exactly will a face classifier do, or how can we utilize that? So what will be done is, using this har cascade, which is har cascade frontal face default .xml, which is part of the CV2 library, we will end up classifying a face or identifying a face. So it is basically face identification. It is not face recognition. Face recognition would be that this little Python code could go ahead and recognize my face and say, okay, this is Rohit. So that won't happen. So all it will do is it will just draw a square across my face, or the face of absolutely anybody who's there, basis the basic structure of the face. So within the face, rest of okay, so let me face towards the light. The rest of us is kind of lighter parts of the face, okay, but the mouth, the nose, and the eyes, the eyebrows included, and of course the hair are slightly darker. So basis that, and basis the har cascade that we provided, it goes ahead and identifies the structure of the face. So it is not necessarily and certain other algorithms would go ahead and identify a face basis on its tan or basis on its color. So for me right now that might not work because I'm wearing a lighter t-shirt, so it might end up my face is darker than my t-shirt, so then it won't work. So, but here, yes, of course it will work, and we'll see that with different different shadows, different lighting, different kind of people, all kinds of faces will be identified. Okay, having said that, there will be certain misclassifications. So the misclassifications or the classification errors wherein there will be false negatives. So it is supposed to be a face, but it might not identify. And similarly, there can be false positives also, wherein there is supposed to be whereas there is no face, but actually a face is identified. So that kind of challenges will be there. Computer vision is not perfect. Yes, of course it is perfect for folks who've gone ahead and built on top of these libraries, OpenCV or CV2 in our case with the Python bindings, and DLIB. So if people have done that, then of course they will get better results. I have heard of people getting results as high as 97%, 98%. Classification they've hit, but any which way, so we'll come to that later on. So basic face classifier and eye classifier, so both of these are inbuilt har cascades which are given, and at a later stage I will also, because there's a lot of this research which is available on the net, which is easy to pick up, it's not that difficult. We can go ahead and create our own har cascade classifiers. So I would also do that, and then I'll kind of let's see if I can open source that also. Otherwise, you can find lots of code which is already there, or lots of blogs which already talk about that. Okay, So the image is the image of Mona Lisa, and this is where I keep my images. So these are all the images that I have, and with these images I'm picking up this one for now. So let me show you what the image is like. So this is what the image is like, and we'll end up running this chunk of code. Okay, and we've gotten initiated this algorithm, and with this chunk of code we'll go ahead and actually look at the image. So let's see what happens. So yeah, this is where it gets displayed. So what we get to see over here is basically this pink square which is there. This has gone ahead and this pink square which is there, it's gone ahead and it is highlighted the face, and that small green square has gone ahead and highlighted the eye. So without giving it any chance of fibbing us, or maybe there is some code which is hidden or something of that sort, what we'll do is we'll choose another of these images. So let me go ahead and look at what other images I have here. So we'll look at the Kennedys. So the Kennedy brothers, the three of them, and we'll look at their image. We'll change this and we go ahead and say okay. Now let's see what happens. I think I got the spelling wrong. Oh, sorry, it's a JPEG. Okay. Yeah, so that's done. And then again, so I'm hoping this works because I have not tried it on this image earlier. And has it come up? Yeah, so we just got one face. We did not get, or do we get more faces? Let me see. So we got one face and one eye. What I was expecting was 3 pink squares and at least 6 green squares, but I need to make some changes to the code. So anyway, so this is okay. So it's gone ahead and identified one more image, one more positive I have over there, and yes, one more. So that was not expected. Wonderful. So it's going ahead and going for more face identification. Let's see. There you go. And there. Wonderful. So it's got both the eyes now and it's got the face. And what I'm actually doing is I'm closing this image. So whenever I close an image, it progresses to the next one wherein it shows us a progressive result. So I hope it does this for President Kennedy also now. Let's see. No, that didn't happen somehow. Okay, anyways, I need to fix this code, and once I'm able to fix this code, I think I should get better results. So this is just the let's just say the boilerplate code. So something which came with CV2. So I have not made any changes. I'm just supplying it with the pictures, that's all. So very basic stuff. So I'll close this first one and let's look at this. So this is car detection. Again, very basic code. Imported those libraries. So what exactly is cap? Cap is the video capture. And this one has a video which is going in. So it is cars.avi. So let's look at cars.avi. Let's be looking at cars.avi. And where did that go? Yeah, here it is. So you see there are cars moving on the highway. There are buses. There are various modes of transport. Somebody is cycling. and what we want are and of course it is inbuilt and it will do that quite perfectly. It will go ahead and identify cars, it will go ahead and identify vehicles. Basically, it will you'll see some squares coming up on this bus also, this, sorry, that lorry, whatever that went through. So let's try this out. Yeah, so you see this classifier, which is this algorithm which is built in, and the cascade which is given to us. It might show a square on that big white lorry which will pass now, but then I think it's doing a pretty good job of identifying these are moving targets, and those moving targets are being identified quite well. And I don't see that it is, no, so the lorry was skipped. So the lorry went by, it did not create a square on the lorry, and that cyclist also was skipped. So it's only the cars basically. So this is, of course, over a period of time they've gone ahead and created this excellent classifier which works out of the box and does a wonderful job. Okay, so later on what I need to do is I need to get some more videos of cars and check out on them. Okay, so this is facial landmarks. Now facial landmarks, this works with the additional shape predictor. It's called shape predictor 68 face landmarks.dat. Now what I would want to look for is a shape predictor which is not 68. So 68 is basically the number of the 128 or something is what I'm looking for. And let's see if we can, what? Oh, sorry. So we are looking for something like 128 something. It's bringing me, I don't want to see the 68, this thing. I want the 120, 128 something. So any which way, so that exists and can be searched on GitHub, and otherwise I think in some of the I think, yeah, so that is for later. So right now what we are doing is we are using the 68 landmarks face predictor. So what it will basically do is it will divide the face eyes downwards into 68 face landmarks. So let's run this, and this one comes with CV2, so you don't have to do anything. And of course this code also, it comes with CV2. And let's look at what gets printed out. So I'm using one of those images of yeah, this is the one. No, did I change it to Mona Lisa or what happened there? Okay, yeah, so of course the next code chunk shows us as to what it is. And one thing that I kind of noticed was that this class of this landmarks is numpy.matrixlib.defmatrix.matrix. So is it one of those simple numpy arrays, or is it something else? So we don't know. So I'm not very sure right now. So in some discussions on the net, it says it's a flattened matrix of the numpy array, or somewhere it says it is the same. So I need to kind of find that out. I was trying to do few things on this which I couldn't, so I wanted to kind of do some further things on this, which I couldn't. So any which way, so we got 68 of these, and that's about it for now. And we need to get more. We need to get somewhere about, I think, 130 to be able to cover the entire face and also different positions of the face. And so that is what I am kind of on right now. So let's see if I can do that. And now we go ahead and get, where did that go? Oh, okay. There it is. So you see the point 0 starts from the right eye's edge, so to say, goes down to the chin, and then starting with point, I think, 6 till about 11 is the chin, then the left cheek, then the eyebrow, the nose down. Yeah, those 33 comes at the tip of the nose for most of these images, and that is how this is. So let's look at some other images. So in place of just looking at Kim Kardashian, let's look at let me look at some other images. So let's pick up from here. What do we have? We have Megadeth. Yeah, so this one came out as a false classified, and I think I know the reason for that. So is that Megadeth 1, 2, 1? Okay. It's got to do with that. What happened? Too many faces. Yeah, okay, so yeah, so too many faces for the landmark, so this might not work. It was working for the simple face detection. So let me get one which is which has got a single face. I have a choice between my face and Mona Lisa's face. I'll go with Mona Lisa. So just to see that it works. Yeah, it does. It's again given us 68 of those. And there it is. So you notice that 33 comes on the nose, starts from 0 on the right eye, goes right up to this, and then this is how the numbers are increasing. And it covers only the eyes downwards towards the chin. So rest of this area, that is the forehead, the hair, the basic visage of the entire face, that needs to be done. And for that we need that 128 or 125 .dat file basically. So if that can be found, which I will, then we can achieve that. Okay, now looking at pedestrians. So pedestrian detection, again, just like the car one, there is an inbuilt walking.avi which is there. So I've gone ahead and done that, and you will see that pedestrians are getting detected. So what basically happens is there are certain chunks of code. If I make a few changes over here in the second one, these pedestrians would move automatically. But what I'm doing here is I'm pressing absolutely any key so that it goes to the next one. So I'll try and do that a little faster to give that effect that these multiple pedestrians are getting identified at the same time. So yes, it is quite effective. But then of course this one has been supplied or has been included along with the CV2 package. So is that the one that we want to use? Maybe not. So we'll use another one. So for I think I'll end up I think probably end up crashing this one and then going to the next one. Otherwise it gets hung because that's a larger file. So I'll stop this curl. If it doesn't get interrupted normally, I'll just probably end up Okay, let's see. So this walking1.mp4 is a larger file that I have, and let's see if this gets run. I should probably just break it up into two different files. Not keep the code in the same notebook. Yeah, there it goes. So this will be slow, but you see on the left side there is the pedestrian. There is one pedestrian, and it will go very slow because my laptop is pretty much low on resources. There's very low memory, and there's another one that it's identified. So that's two, and when it starts really starts moving this file, or when I have smaller chunks of this file, this MP4 that I have got from YouTube, you can see that the pedestrian detection is much faster. But still, what I'll do is I'll kind of pause this video and come back. So this one doesn't seem to be moving as of now. So what I'll do is I think I'll stop recording this video for now, and later on upload a video. So this is actual pedestrian detection on a file that I randomly picked up from YouTube. So just a random file. So absolutely anybody can try that out. And that's about it for OpenCV and DLIB for now. We've shared a little bit of R code and some Python code, and let's build upon this in the next few videos. Thanks.